Hi, in this video I'd like to tell you how to use static code analysis and SAS methodology to make your code more secure and enhance its quality. What does it mean, more secure and of high quality? This means that your codebase will be less vulnerable to hacker attacks and other errors. The security problem is quite acute, and many campaigns have begun to show their interest in this topic. This is due to both the increased activity of hackers and increased requirements for software quality. In this graph, you can see the growth of detected vulnerabilities over the past 10 years. What stands out here is the significant growth in the last few years. This suggests that the interest of finding vulnerabilities has increased and more of them have been found. The situation is also complicated by the fact that the code base of program is getting invariably larger. For example, if you look at the code base of the Linux kernel, in the first versions it was only thousands of lines, and this amount of code and its quality could be controlled by several people. But with the growing size of the code, when it comes to millions of lines of code, manual control is almost impossible. Therefore, it's necessary to refer to the use of different tools. One category of those tools is static analyzers, which we talk about today. Let's start with vulnerabilities and approaches to finding them. The first one is a classical one. You're just looking for already known and detected vulnerabilities, but that's a big problem. You can't find new vulnerabilities because you're just looking for already known and detected base. There's also a second approach, which is opposite the first. It allows you to find new vulnerabilities, but it requires to looking for potential vulnerabilities, some defects in the code that can lead under certain circumstances to real problems. Let's talk in more detail about vulnerabilities and the first approach. What is vulnerability? It's a hole in the security of your application, which can lead to the denial of service and privileged access, and etc. The most common way to classify them is the CVE list. It's a list of large number of vulnerabilities which were found in the real projects, supported by Mitre, non-profit organization, and the community. It provides the examples, code snippets which the problem were found, and an explanation how you can exploit them. It's clear that if vulnerability in this list, it already has been fixed by the developers. Let's look at an example of one such vulnerability discovered in the MySQL project in 2012. This vulnerability allowed to remove attacker to by password security check by knowing their username and, in one case out of 256, to successfully authenticate with a random password. We can see that the check scramble function returns the myBool type, which is actually a char type. At the end of the function, the value of the memcmp function is returned. Whereas it is this integer type, the problem is that when an integer is implicitly cast to the char type, the high bits will be cut, which under certain circumstances will allow to an attacker to guess a password. So, we've talked about the first approach to finding the vulnerabilities, but there's a significant disadvantage: we can't find the new vulnerabilities with it. So, let's now talk about the second approach to finding vulnerabilities. It's based on searching the potential vulnerabilities using Static Application Security Testing Tool, also known as SAST. Of course, not all errors in your code base will become vulnerabilities, but if you can eliminate all of them, it would be good. This is exactly what the static analysis and the SAS tools were made for. The advantage of them that they allows you to use the various of standards for both safety and secure testing. In other words, you can make a code more secure and more safety. SAS tools also inherit all positive qualities of static analyzers. For example, errors can be found at the stage of writing code using incremental methods. The disadvantage of these methods also inherited from the static analyzers. Among them, you not always can say is it an error in front of you or not. So, it's always require an additional analysis by the person. Therefore, the important criterion of SAS tools is a number of false positives. So the developers of such tools trying to minimize them. For good analyzers, it doesn't exceed from 10 to 20%. So, how do static analyzers work? Imagine that you have the following code from the real Mono project for review, where you need to detect an error. You know that there is definitely an error because the method doesn't work correctly. There is indeed an error here, and it's very difficult to find it with your own eyes. But SAS tools can help us with it. Let's review the highlighted example in more detail. It's obvious that the developer copied the line twice and forgot to correct the value. As a result, it's assigned the same value regardless for the conditions. PBS Studio Analyzer indicates that this line contains a potential errors by issuing the V30 and 12 warnings. Of course, when such code contains an indication of the error location, it is much easier to fix it than if we are dealing with just a solid piece of code. Let's look at another example of a real vulnerability that was found in the IOS in 2014. The vulnerability allows an attacker from a privileged position in the network to intercept and modify packages in SSL TLS protected sessions. If you look at the code, you can immediately see what the problem is. We see that the goto operator is used twice by mistake, and the second goto is unconditional. As a result, part of the code became unreachable. The analyzer can also warn us about this error by issuing 2 warnings. Thus, this real vulnerability could have been prevented by fixing this error at the stage of writing the code. If you decided to use SAS tool, let's talk about an introduction. One of the problems people face is the large number of warnings in the legacy code of their projects, which they won't be fixed in the introduction stage. So, what shall we do with it? For example, PBS Studio Analyzer allows you to suppress all these warnings into a special file and postpone fixing them until better time. This allows you to introduce static analysis more quickly and focus on fixing new problems. It's also very important to use the static analyzer both on developers' machines and on night builds on the server. Using on the server actually prevents errors to getting into release, and using on developers' machines reduces the cost of fixing them. The presented graph proves those statements. We see that fixing an error at the earliest stage of development costs almost nothing. If an error or potential vulnerability has passed to the next stage, the company begins to incur losses associated with fixing this error at later stages. For example, when the QA department gets involved. Yes, the error is detected and fixed, but it will cost more. The worst situation is when a bug gets into the release. Not only will it result in significant financial losses, but also in reputational ones. We also encourage you to remember that SAS tools are not a silver bullet. There is a huge scope of problems that they cannot detect, memory leaks, concurrency problems, and etc. So you need to use as many available methods as possible, for example dynamic analysis, test-driven development, and so on. Thank you for watching to the end. If you have any questions, don't hesitate to contact us in support.